Hello, my name is Michael Manchiraju, and this is the Physics 2212 Lab 1 Charged Tapes. This is a brief introduction of the lab. The purpose of this lab is to observe the effects of an electric field on two charged tapes and calculate the charge of the tape. A preview of the results is that opposite charges attract and like charges repel. The average distance between two tapes is the same charge, is 0.0413 meters. Some assumptions here: that we ignore air resistance on a moving object. We treat a long tape as though it were a point charge with all the charge concentrated at the center of the long tape, and assume that each U-tape that we made had about the same amount of charge evenly distributed along the length of the tape. So all three of these assumptions are ones that we took into account. And so here are some key ideas that were used in this lab. The first is Coulomb's law, which describes the electric force. The other one is an electric field on a point charge, which describes the vector of the electric field. And the third one is Newton's second law, which we will use to calculate the gravitational force and the electric force. So here's the experimental design. You had a U-tape, which is just a tape that was electrically charged. We did this by using the procedure outlined in the lab booklet. And you put the tape on the edge of the table and put your hand near the tape. And here were some observations from that. The U-tape and your hand attracted the U-tape. Between the U-tape and another U-tape, they repelled each other. Between a U-tape and just a random book, there was attraction. And between a U-tape and a negatively charged pen, there was attraction. Based on these observations, especially with the pen, it can be concluded that U-tapes are positively charged. Some initial measurements here were the length of the tape was 0.20 meters, the width of the tape was 0.02 meters, and the mass of the tape was 0.0002 kilograms, and we used the density given of some Scotch tape. The system is the hand and U-tape, or the two U-tapes. We're going to see that in the next slide. And the surroundings is the rest of the Earth. Here is the other experiment that we did. Here you have tape A and tape B. Tape B was positioned between two books, and you had tape A, and they're both U tapes here. And you can actually, since they're both charged, you can actually repel each other. So B will look like it's floating. Based on these observations, it is confirmed that the 2 point charges that will have the same charge will repel each other. We modeled the tapes here as point charges. Initial measurements, again, all the same here. And here I did 4 different trials. The average distance in between tape A and B was 0.0413 meters. So here is the coding and calculations. So first in the code I did some basic calculations. So I used Newton's second law to calculate the electric force and gravitational force. The tapes are modeled as spheres. The charge of the tape, modeled as a point charge, is calculated using Coulomb's law, and the number of electrons is also calculated. You can see the code right here and right here. And of course, I used a function to calculate the electric field. Again, we modeled the tapes as point particles as seen here. And so here are the final results. The gravitational force on the tape is just points in the downward direction. This is this yellow arrow right here, and it can be seen right here. The electric force on the tape is points in the upward direction, and it can be seen right here in the blue arrow. The charge on the tape is 1.91 e to the negative 8. The number of electrons on the tape is 1.196 e to the 11, and the electric field vector equals 0, comma, negative 1.02 e to the 5, 0. And here are the conclusions. Like charges repel each other and opposite charges attract each other. Some possible errors here. Each piece of tape may have had differing charges, but they were assumed to have equal charges. The tape could have also been handled differently. What if electrons had positive charge and protons had negative charge? This would have no effect on the results. And why is it important to handle the charged tapes as low as possible? When the tapes are touched, the extra electrons are given the chance to escape, and electrons can flow into the tape. This neutralizes the charge. All right, thank you.